Hi everyone, and welcome to the third video of the workshop Introduction to Machine Learning. My name is Pleuni Pennings, and I'm a professor at San Francisco State University in the biology department. I work on viruses and bacteria and drug resistance and evolution, but today we're going to talk about the COVID pandemic and how to use machine learning to make predictions. I hope you've already seen video 1 by Lorena and video 2 by Lucy. And after you watch this video, you can watch the final video that Florentine has made. Okay, so just to recap, let me move myself here. So what we're going to do, or what we are doing in this video series, is we're looking at data from counties in California. There are 58 counties in California. We are using data from 40 of these counties, information about these counties on how many COVID cases they had, and other information about these counties. And then we're building a model, a machine learning model, a decision tree model, to be specific, to try to predict the number of COVID cases in these counties. And then to see if this worked, we're using the same model on 18 counties. And for these 18 counties, we're like pretending that we don't have the data. We don't know how many COVID cases there were. We're trying to predict how many COVID cases there were. And then we look at the actual data and we see how good a job we did. Okay, so this is the result that you've already seen in Lucy's video. So here there's the list of 18 counties, and for each county in dark blue is the number of actual cases in the summer of 2020, the number of COVID cases per 100,000 inhabitants, and then in this yellowish orange color is the predicted number. And so what you can see is that this model is not doing a perfect job, but it's doing a reasonable job. For example, you see here that in plumas, the prediction is low and the actual number of cases is also low. Here in Contra Costa, it's like nearly perfect, or maybe entirely perfect. Imperial has a lot of cases, and it's also predicted to have a lot of cases. Okay, so our machine learning model is doing reasonably well. Okay, so this is what the model actually looks like, right? So we made a decision tree, like the program that we ran made this decision tree. And so it tells us that with the data that we gave it, to make predictions using a tree model, what it says is like, well, let's first look at the unemployment rate. If it's low or lower than this value, we go here. If it's high, we go here. So let's go for a low unemployment rate case. If the population size is low, we go here. If it's high or higher than 28,000, we go here. In the low case, it's asking us to split up again in like really small county, like lower than 6,295 people, we go here. And so each county that you want to make a prediction for, it's like put into this tree starting from here, and then depending on the information that we have about that county, it will go somewhere. So in the end, a county may end up here, and then the predicted number of cases based on this model per 100,000 inhabitants in the summer of 2020 would be 160 cases, 160.514. Of course, we can never have 0.514 cases, but that's just that's a prediction that it made, right? If the county ended up here, a county that is similar but slightly bigger, then the prediction would have been this, 286, etc. So this tree, if you had information about a county, then you could make a prediction now that you have this tree. One thing that is important to know is that these kind of machine learning models, they don't care about causality. So if feature A predicts B, so say if, a small county, leads you to predict that there's few cases, or if high unemployment rate makes you predict that there's a lot of COVID cases. That doesn't mean because these things cause the COVID cases, right? The model is just about finding patterns, and it's not about actually finding what causes another thing. Okay, so this is what we did. Now what I would like to do is use the same model and see if we can make predictions also for the summer of 2021. I mean, I know I can make predictions. I'm going to see how well they do. So let me get out of this presentation and I'm going to go to the code, the student workshop 1 notebook. Let me open it. And I'm going to go here and open and make sure that I have the table of contents open because it helps me know where I am in the notebook. Okay, and so most of this you have already seen in Lucy's video. So I'm going to go all the way to step 7. And I'm going to say run before. So it will run everything up until this cell. Anyways, if I run this now, it will create this plot. We've looked at this. Remember, like Plumas has like this low predicted number and low real number of COVID cases in the summer of 2020. Okay, there we go. So now step 8 is let's try to use our summer 2020 model to predict 2021 data. So for this, we need to get the data from 2021 for these 18 counties that the same 18 counties that we had as testing data set for 2020. So here I'm going to, this line actually imports that data, and then this line makes the predictions for the labels using the 2020 model. Okay, that worked. And now all of this code, you've seen this before, it's just copy pasted, but then putting 2021 everywhere. And so I can run this and it will make this new plot with the predictions and the real numbers for the 2021 data for these 18 counties. Okay, so let's look at the outcome. And here in yellow is the prediction. And in this darker greenish color is like the real number. And so I hope that what you notice is the same as what I noticed, which is that it didn't work very well. These predictions are all much lower than the real numbers. Right? Look at Plumas. Plumas had a very low number of cases in 2020, and the prediction here is actually the same prediction as that we had for 2020 is low, but the reality for 2021 is much higher, right? And almost all of them have like these much higher numbers in 2021. I see only one of them where the prediction is higher than the reality. That's in Imperial County. Okay, so clearly this 2020 model does not do a good job for the 2021 data. So why is it the case? At this point, we don't know exactly. So one thing that we can do is we can actually take the data from 2021 for these 40 counties and do the same exercise. We can make a decision tree for that is specifically trained to work with 2021 data and see if we could do a better job with that new decision tree. Okay, so here again, just to have them side by side, this is our predictions for 2020 using the 2020 model and comparing it with the data for 2020. And so you can see that, you know, the predictions in yellow and the real reality in blue are not too different. So the model is doing a reasonable job. But then here on this side, you see the predictions in the reality for 2021. And you can see that in many cases, the reality means many more cases than what the model had predicted. And so, you know, what I hope you realize is that this 2020 model that we created by using 2020 data to train it did a reasonable job for 2020, but didn't work well for 2021. So what you'll do in the next video with Florentine is you will actually redo some of the code to actually train a model for 2021 as well. So, she'll go through the notebook and she'll copy paste code that Lucy has made, but change it so that it works for 2021 to create a new decision tree for 2021. And what you'll find is when you make this decision tree, that the root node, the most important piece of information that the decision tree uses, is actually how many people were fully vaccinated by the summer of 2021. So I hope you remember that from 2020, the most important the root node asked about the unemployment rate. So in 2020, the unemployment rate and probably other things that are related to poverty were important to predict how many COVID cases there were in a county. But by 2021, the situation had changed and the vaccines now played a very big role. And in counties where a lot of people were vaccinated, we'd had fewer COVID cases. And so now this root node actually asks about the vaccination rate. Okay, so when we redo this decision tree, we make a new decision tree that is trained with 2021 data, and now we make predictions for 2021. We get this situation here on the right, and again, Florentine will show you exactly how to do this. And now the predictions and the realities are much closer to each other again. So I hope that this makes you realize that machine learning can be powerful, and with just a little bit of data for counties, we can make a prediction about the number of COVID cases. But then when we tried to use a model that was trained with 2020 data, it did not work at all for 2021. And the reason is that the world had changed for the COVID situation, because in 2020 we did not have vaccines, whereas in 2021 we did. And so the most important drivers of the pandemic had changed. And so that's why we could not use the model for one situation in another situation. And that is important, when someone makes a machine learning model to predict, say, which patients will benefit most from being treated in this way or this way. The model may do really well in this one hospital, but then if you move it to another hospital, maybe it doesn't work well because the situation is different. Okay, I hope you will have time to watch the final video, but if you don't, I hope you still feel like you've learned something about machine learning. I hope you've enjoyed playing with the data and doing some coding in Python, and thank you for watching.